Hi guys, welcome to the second session of complex numbers. This is going to be a short video, so that's a good part. In this particular part, we're going to look at operations of complex numbers. So we're going to look at addition, subtraction, multiplication, and such operations on complex numbers. And at the end of this, we are also going to see a very interesting small fact about it, right? So let's go into the lecture. A very quick screen slide about me. I'm going to skip this part now. Right. So we're going to first start by looking at addition and subtraction of complex numbers, and it is not at all difficult. It is very straightforward. So the thing to keep in mind about adding and subtracting of complex numbers is you need to add the corresponding real part and the imaginary part. So they have to be separately added and then combined. Let's take a look at what do I mean. So if you have 4 plus 8i, let's call this as Z1, the first complex number, and this is your Z2. So the resultant Z3, which is equal to Z1 plus Z2, will be written as 4 and 6 added will be giving you 10. 8 and negative 2 will add up to give you 6. But this is 6i or i6. So this is the simplest way of adding and subtraction of complex numbers. It is not at all something new. You know how to do this. Okay. So if you look at even rational part, irrational part, doesn't matter. If there is a root 2 and a 5, now you cannot simplify these two further. So you will leave it as it is, root 2 plus 5. This becomes the real part. And imaginary parts will get added together. So I can be taken out common. So you will get root 6 plus 10, which is the imaginary part. Okay. So this is the way in which you add or subtract complex numbers. Right. So that's not at all difficult. Now let's look at multiplication of complex numbers. Is it any different? You will realize that multiplication of complex numbers also is not different at all. It follows the same properties of multiplication of variables. So any two variable multiplication. So if you have a Z1 multiplied with a Z2, then like in the multiplication of A plus B into C plus D, what you do here, you multiply every variable, right? So you have AC plus BC plus AD plus BD. This is what you get. Similarly, 2 and 4 will get multiplied. 2 and I2 will get multiplied. Then I6 and 4 will get multiplied. I6 and I2 will get multiplied. So it's the same concept. Nothing is different in this. So you will get 2 into 4, I into 6 into 4, 2 into I into 2, and I6 into I2. Now here 2 into 4 becomes the real number 8, and these two will have only a single I in them, so they will together become the complex part or the imaginary part. Now this I into I part, we know that I square is negative 1, so this part becomes minus of minus 12, which is plus 12. So this plus 12 and 8 will get added and you will get the answer 20. Whereas this negative 24 here and positive 4 here will get added to give you minus 20 or negative 20i. So the resultant of the multiplication is again a z, which is going to have a real part and a imaginary part. Right? So that's how the multiplication of complex numbers are done. Now here I want to showcase an interesting argument that you might come across in certain cases or certain forums, and you might question yourself what is going wrong in this. So let's look at the argument first and try to understand what is this all about. So I start with I square equal to minus 1. This is accepted. All of you know this. I square is negative 1. Then I can write negative 1 as I into I can split it because I square, I can split it as I into I. Now we all know I equal to root of negative 1. So I will write it as root of -1 into root of -1. And we all know that root a into root b is equal to root ab. We all know this. So I will take the root common and will multiply -1 whole square. Now in mathematics we know root of -1 whole square, basically what happens, root of -1 whole square will always be root of 1. And this is supposed to give me the answer as +1. Because small thing to keep in mind, guys, in mathematical operations, root of any number, if I give you root of, let's say 9, this is only +3, it is not plus or minus 3. If I give you root of 16, this is only +4. If I give you root of -8 whole square, this is only 8, because it becomes root of 64 and then root of 64 is 8. So root of any number is always positive. It is never negative. Now you might question, when is it negative then? When does it become plus or minus? It becomes plus or minus if the question starts with x square equal to 16. In this case, you'll get x equal to plus or minus 4. Similarly, if I say x square equal to 9, then only you can write x equal to plus or minus 3. But if the question starts directly with root 16 or root 9, your answers will be only +3 and +4. Please keep this in mind. So by that logic, if I look at this root of -1 whole square, I will get it as root 1, which is therefore 1. Correct? So then what am I saying? I'm starting with a -1 and I'm ending with a +1. So does it mean that -1 is equal to +1? Is maths gone? Are you free then? If -1 is 1 and it is logically proved and nothing is wrong in this, then there's no more maths for you. Everything is in the air. But that is not so. Pause the video, think for a moment, what is the mistake that we are committing? Now, for those of you who realize the mistake, congrats. Others, please realize, when I wrote root of a into root of b is equal to root of ab, this is only valid. Please remember, this is only valid when a and b are positive numbers. A and B are non-negative, not just positive, non-negative. 0 is also valid. So as long as A and B are non-negative real numbers, only then this expansion or this way of simplification is valid. Otherwise, you cannot simplify like this. So if I say A is less than 0 and B is less than 0, then root A into root B cannot be written as root of AB. This is wrong. So most often than not, these small points are not taught when you are a kid, because that's when you learn. Basically, root multiplication you have learned in 5th or 6th class when the root is introduced to you. But these small points will not be taught to you because it does not matter at that point when you're dealing with only positive numbers. But because you're not being taught at that point, you will never learn it in your life. And here, when you come across questions like this, where it matters, you will be having a problem. So here I'm clarifying this. Remember, root of a into root of b is valid as root of a plus a into b only when a and b are positive. Right? So that's an interesting thing which actually I was browsing through a few forums and there's a discussion happening on this. So I thought I will put this as a small slide in the session. Well guys, so that's all there is to operations. The operations are very simple, as I already told you. We did not discuss division. Please keep in mind that division as an operation, we will be covering it a little bit later. It comes under the part of conjugates. So right now we have seen only addition, subtraction and multiplication of complex numbers. See you in the third video, students. Thank you.